All right, thanks for coming, everyone. I'm Julius Volz, one of the co-founders of the Prometheus monitoring system. And this is really like an intro-level talk. If you're already using Prometheus and you already kind of know what it is, maybe it's not so useful. So I'm just giving you a chance to leave now. Anyway, so in this talk, I'm going to just tell you what Prometheus is, what are the basic components, why it's awesome, why you should use it, how it came about, and then, hopefully we'll have some time for questions in the end. So what is Prometheus? Prometheus, I would say, is a tool set or a whole ecosystem that cares about all the aspects of time series-based monitoring and alerting. So we give you tools for getting metrics out of the things you care about, like processes and machines and networks and stuff, but then also infrastructure to collect those metrics, to store them, to make them queryable, do useful stuff with the collected data, and also, besides dashboards, also offer alerting features. And Prometheus is especially well suited for dynamic cloud environments. We do not do certain other kinds of things. Just want to be clear on this. Prometheus only does metrics. That means like individual values that change over time, but that have some kind of time series identifier. We do not do logging, where you want to store like all the details of an individual event, or request tracing. So for logging, you might use something like Elasticsearch. For tracing, maybe something like Zipkin. And we still recommend like having metrics, logging, and tracing in your infrastructure. We allow you to define alerting rules that could be possibly very complex, but they're always very explicit. So Prometheus doesn't do any magic machine learning style anomaly detection, just looking at your data, saying like, oh, something looks really weird here, let's page someone. Also, the Prometheus server itself is a kind of a one-node system, and you can scale it manually, but it's not a horizontally scalable system where you just press a button, add more machines, and it kind of clouds up. And thus, also the storage by default, as it is in Prometheus itself, is not a durable storage. If you lose the node, that part of the storage is gone. It's more of a really real live monitoring system. But we do have ways of integrating long-term storages that I'm going to mention later. So we started Prometheus in 2012 at SoundCloud out of a real need. Matt and myself just came from Google at that time, and SoundCloud was a company who already had in-house built like a cluster manager, basically, before Docker or Kubernetes or Mesos really existed. And they had hundreds of microservices running on there. And we needed something to monitor that. I'll get to that in a second. So we started it at SoundCloud, brought it to relative maturity, beginning of 2015. We really published it. It took off, Hacker News and all that. Now it's part of the Cloud Native Computing Foundation. Many companies are using it. It's kind of, for many people, it's almost like a default. If you're using Kubernetes, it fits in very well. And yeah, plenty of contributors, big project. Maybe I should say here also, it's a bit special in comparison to some of the other CNCF projects in that it didn't really have one engineering company that intentionally created this thing to put in the open source world. It was more of a byproduct, like we created it because we needed it, and then we thought, oh, let's open source this, but SoundCloud wasn't really in the business of creating open source infrastructure software. So now it's really one of the most independent software projects. So yeah, the motivation was really, SoundCloud already had this in-house built cluster scheduler. They had hundreds of microservices, thousands of instances, and we were just trying to figure out why SoundCloud was down all the time or slow or whatever. And it was very hard. Like if there's a latency spike, using the existing monitoring tools back then, Graphite, StatsD, Ganglia, New Relic, et cetera, they either in terms of the data model or in terms of the query language or the amount of history they could take into account, didn't really give us the detailed insight that we needed to figure out where exactly what was going wrong. So finally, we decided to build a new solution, which eventually became Prometheus, to tackle all these issues. I would say, let's first have a look at the overall architecture. You run one or multiple of these central Prometheus servers. That's the block in the middle. It's kind of the heart of the Prometheus ecosystem. In your company, for example, like every team could have one, or every service, depending on your organizational or scaling needs. You can configure these in scalable trees or other kind of scalable architectures, but let's just start with a single one. You configure that Prometheus server to fetch metrics over HTTP in a format that we define. And the metrics can really come from any kind of thing that can serve metrics over HTTP. So, typically we recommend you to, if you have your own applications, like an own web app, API server, put metrics directly into your own code, white box instrumentation that tells you exactly what's going on inside the application. Those are the best metrics. And then Prometheus can also go directly to your code and knows like, oh, if I cannot pull from your thing, it's down, and all these nice side effects. For some things, you cannot directly do that. You're not going to put Prometheus metrics into the Linux kernel or into the MySQL daemon, right? And for that, we have this exporter model where you run a sidecar job right next to the thing that has metrics in some other kind of format already, like the Linux kernel over the proc file system. For example, the node exporter does that for host metrics for Linux. Then Prometheus scrapes the node exporter, and the node exporter in the background just goes to the proc file system and there's some other syscalls to figure out actual host metrics, translates them to Prometheus metrics, and ships them back synchronously to Prometheus. Prometheus has a local time series database where it stores all these time series over time. It's a configurable retention, could be like weeks, sometimes months. Some extreme people do years, not really recommended. Then you can configure Prometheus to calculate alerting rules over the collected data, and the alert manager component, which is a separate binary, then does the final dispatching of notifications based on their details. It chooses which team and what kind of notification mechanism, Slack, email, PagerDuty, etc. it should go to. And then you can integrate with like Grafana, the HTTP API, or even a built-in UI in Prometheus to display the data in dashboards or do other useful stuff with it. I would say these are my favorite selling points of Prometheus over other monitoring systems back in the day, at least, and still nowadays. I think the first two kind of go hand in hand. Prometheus has a dimensional data model that allows you to record in relatively high detail for a time series-based system what is happening where. And then to make sense of that collected high detailed data, we give you a powerful query language to compute whatever you kind of currently want to know about that data. A single Prometheus server is pretty simple to operate and still relatively efficient. I'll get to that later. And a point that makes Prometheus specifically work really well in dynamic cloud environments and cluster schedulers is the service discovery integration, how it knows what it should monitor all the time. So I'm going to hop through all these 4 points in a row and go into some details. First, the data model. We store time series. That's nothing revolutionary. All time series have some kind of identifier. And then there are just like timestamp value, timestamp value, timestamp value. And in Prometheus, all the timestamps are in 64s in millisecond precision. That's just, keep it simple, that's it. That's all you need for systems monitoring. That's what we say. The value type is always a float 64. That works for pretty much everything. You can increment that like for, I don't know, forgot like 285 years, 1 million increments per second before you reach the first non-consecutive integer. So at that point, you should like reset counters at some point or so. So it doesn't really become a problem. But yeah, so the big difference is kind of how we identify time series compared to systems that came before. Let's compare it to the graphite and stats metrics model, where you had a long metric string that had some dots in the middle to separate components that formed an implicit hierarchy. In this example, you have like HTTP requests happening on Nginx servers on different hosts. That's the IP component there, and then different paths and different status codes. But The hierarchy here is implied and implicit. You need to kind of know what each component means. It also, why would the status code be lower in a hierarchy than the path, for example? Or why wouldn't the host come first? Also, if you add another component, would you add it in the end, in the beginning, somewhere in the middle? It's kind of hard to extend as well. In Prometheus, we go a bit of a different route, where we put the metric name front and center. It's basically the central aspect of a system that you are monitoring, like the number of HTTP requests we have counted since a given process has started. And the process exposes that. And then it can put key value pairs on that metric to further differentiate dimensions on that metric. For example, the process itself would add the path and the status labels onto these metrics, but then Prometheus, when it scrapes the target, also adds some labels of that target, saying like this came from this service, or which we call job, this job, and this particular process, the instance. So you're getting some labels from the instrumentation in the process and some labels coming from the Prometheus server because it knows what it actually just scraped. And yeah, this gives you a more explicit mapping of keys to values, and there's no hierarchy anymore either. Now, if you query, that becomes a bit more obvious why one is nicer than the other. In the kind of graphite model, you have to know where to put asterisks. Let's say you want to query all the HTTP requests for all the engine X's that ended with a 500 status code. It would look like in the top for graphite. It's kind of implicit. You need to know what it all means. For Prometheus, you start with a metric name, and then you just add random label filters. You could also have negative or regex filters here, just selecting the time series that you really care about. And you don't even have to know what other labels exist on those time series. So really, you want these kind of key value labels as first-class citizens, which also fits nicely with Kubernetes and Docker, which also have the same label concept. So now we have collected all the useful data. Now let's do cool stuff with it. Prometheus defines a new, completely custom query language. It's not SQL-based, which is a bit of a, like some people get surprised by that, but we think that what we have works better than a SQL-based language for the kinds of computations we typically want to do in time series-based monitoring. Let's have a look at some simple examples. Let's say we have this node exporter running on all our machines in the cluster, and it tells us as one metric, for example, like for every file system, what's its total capacity. And then there will be all these labels on it, the mount point and the device and which actual machine instance it is and so on. And now we can just ask Prometheus, hey, either give me everything, then you would just list this metric name. But then we can add filters, like do not give me the ones that are mounted on root. Divide that whole set of time series by 1 billion to go from like bytes to roughly gigabytes. And then, well, I only want the ones that are actually larger than 100 gigabytes. And this would give me all the partitions not mounted on root larger than 100 gigabytes in all of my infrastructure. And the output also contains the useful labels. Another common thing you want to do in Prometheus is to calculate the ratio of two rates, for example. Like you have your error rate and you have a total rate, like in this case. And you want to know the ratio. How many errors am I getting in comparison to the total? And this is something you can do with a binary operator, like a divided by here, which isn't so spectacular. Like if you sum over all the time series of all the rates that are bad and sum over all the ones that are good and then divide, you get a single number out. Meh, okay. Sometimes you want to split that up by different dimensions. For example, you want to keep the path, you want to have the error rate ratio per request path. Then you could add a modifier to this expression, saying by path, could add different labels in there as well, and then it would preserve this dimension. And this is where some of the actual cool automatic join magic happens in PromQL. If you have a binary operator between two whole sets of time series, then it will automatically join them up on identical label sets. So, the 500 error rate for the path on the left will be divided for the total rate for that same path on the right, and that gets propagated into the output. So it's kind of this vector-based arithmetics language. You can do more fancy stuff. For example, you can track latencies with histograms in your instrumentation and then use a query function during query time to say, like, give me the 99th percentile, for example, aggregated over all the instances and as averaged over a 5-minute time span. So you can choose the percentile, the aggregation level, and the overtime averaging during query time. And then you get these answers. So these are just some examples. You can combine many more crazy constructs into very long, crazy PromQL statements. But this, I think, does for a beginning. Now, once you know a bit of this language, you can start looking at data with it, either in this built-in expression browser in Prometheus itself, that's in the Prometheus server. For example, just looking at the current value of everything in your infrastructure. There's also a simple built-in graphing interface. But then once you want to have more bells and whistles, nice dashboards that you can save and share with your colleagues, of course, you'll want to use Grafana. Grafana has native support for Prometheus backends, so that's like what we recommend for people to use for serious dashboarding. And then the cool thing, I think, is that Prometheus also integrates alerting in a unified way with the query language and based on the data that is collected. So, in a Nagios-style world, you would run periodic checks on machines that don't really have much history. They just check if something is currently running or the CPU is currently high or so. In Prometheus, it's a bit different. We collect all the data as time series first, and then you can formulate any PromQL expression on top of that data that can take into account different amounts of histories or also different aggregation levels. You could say, like, is the whole service bad or is a particular process bad? And you can decide on, or something in between, right? And decide, like, what's the relevant alerting level. The way that works is you say, like in this example, we say we want to create an alert, many 500 errors. You configure that in your Prometheus server. It will evaluate it every couple of seconds. It will run this PromQL expression that is in yellow here. And this is a repetition of something I had earlier where it calculates like that per path error ratio. I multiply it by 100 to get from a ratio to a percentage, and then I filter it to only get the paths that have more than 5% errors. And an alerting rule in Prometheus works this way. Like, if there's no output from an expression, everything's good. But any time series that gets outputted from the expression becomes an alert. And then an alert manager, where Prometheus sends these individual alerts, they can be grouped into single notifications. Like, if you have an alert per machine, for example, that's down, and there's 100 machines down, then alert manager could like group that into a single notification. You can also say, every output element has to be bad for at least 5 minutes. That's the statement, the for statement there, before actually, bugging someone around about it. That's important for some kind of robustness. And you can add extra labels and annotations that can be used in alert manager routing and in the actual human-readable snippets that you get in your alerts. Prometheus is, single static Go binary kind of server, and you just run it on a machine. It doesn't do any clustering because we think that's really hard to do right, and the clustering might also be the first thing that breaks in the face of a network outage. So, if you want to have high availability for alerting, everything in Prometheus is built around high availability for alerting, not necessarily for infinite data retention or something. But there we just, if you want HA for alerting, you run 2 identical Prometheus servers that don't know anything about each other, but have the same scraping configuration, and they might have slightly different scrape phases, but conceptually they collect the same data. And they can compute the same alerting rules and communicate to the same alert manager cluster. And then alert manager will deduplicate based on the label sets. So you don't actually get 2 notifications if both are still running. Yeah. But yeah, like getting started with Prometheus is pretty simple. There's like people running it on a Raspberry Pi at home. Of course, it gets more complicated once you have really big setups and you need to think about scaling and topology. A single server is relatively efficient. Like we can do, yeah, it depends on the hardware, but if you have a big machine, you can do a couple of millions of active series at a given time and over 1 million samples ingested per second. And then we store those samples as roughly like something between 1 and 2 bytes per sample on disk. It's a custom time series database. So this is good for keeping weeks, months. Some people go out on a limb and keep like only few metrics, but for years. But then we tell them like, yeah, there's no durability guarantees. For people who do want to keep data more durably and longer, there's some decoupled remote storage support, where you can tell Prometheus to ship all its samples to a remote endpoint, and then that can choose to store it in a remote system. For example, we have like InfluxDB supports that now. There's, yeah, we have adapters for Graphite. There's Cortex from Weaveworks. There's several systems that like basically over 10 integrations in this space now, that allow you to write Prometheus samples to a scalable, durable backend system, and some of them also allow you to read that data back through Prometheus again. Prometheus, as I promised, works really well in dynamic environments. You know, nowadays we have on-demand VMs that scale up and down all the time and disappear. And then on top of that, we have cluster schedulers like Kubernetes and so on. And then on top of that, we run hundreds of microservices and all this craziness. And your monitoring system still needs to figure out somehow what should currently be there. What's the source of truth that I should be expecting so that I can tell you that something is not there, for example, right? So how to make sense of all this? We integrate with service discovery in Prometheus. So Prometheus can talk to various different types of service discovery, like DNS or Kubernetes, to know what should be currently in your infrastructure. And it pulls, you know, it uses that information to pull from those instances. And then if it, for example, if the pull fails, it already has one automatic health signal that you can use that it records as a metric, saying like this pull failed, that you could use in alerting or just looking at your infrastructure, what's currently missing or down. And if it's a good service discovery, like the Kubernetes one, it will also give you like really cool metadata about the things it has discovered. Like it will tell you what kind of pod it is that you're monitoring. It's like environment, production, type, name, Nginx, whatever. And then you can choose, if you want to add that as labels to your time series. So then you can actually select and aggregate on that data. So we support, I think, like roughly 10 different types of service discovery. Some are kind of like node level ones to discover, you know, instances on machine providers, AWS, Azure, Google. Others are more cluster manager ones, Kubernetes, obviously. And then there are generic ones. DNS is pretty agnostic, and Console Zookeeper. You can even build your own one if Prometheus doesn't support it yet with a file watcher-based interface. So like in conclusion, you know, Prometheus helps you monitor and make sense of infrastructure that is dynamic and complex with these 4 nice properties. And yeah, basically that's it for today. And I'm happy to take questions. Yep. Yeah. So there's like the alert itself, and then there's a final incident management portion, which can happen outside of Prometheus. The alerting in Prometheus itself is really based on kind of a sliding window system, where it really just checks, is something bad right now, given the window of time that you're currently looking at in a sliding window fashion. And if at some point the badness shifts out of that window, the alert will also resolve in Prometheus. Unless you build like a fancy feedback contraption where you record a new time series that feeds into, you know, this, which gets a bit weird. Yeah. Oh, okay. Yeah. So as long as the problem persists, Prometheus will actually, like every evaluation interval, like which could be 15 or 30 seconds, send to Alert Manager like this problem is still active for this particular label combination. And then in Alert Manager, you configure for a given grouping of alerts by labels, which you can choose there, repeat this every 2 hours, for example, or once per day if this problem still persists. And you can also say there, like, for example, if 100 hosts go down and you have an alert based on all of them, but you want to group them in Alert Manager, then you can say, well, maybe first I get alerts about 70 of them being down, and then I don't want to send out a notification yet, because maybe 30 others will come just like a couple of seconds later. So you could say in Alert Manager, like, wait 30 seconds in case there's more alert elements coming into the same grouping, so you can still group them together, and these kind of features there. But at some point, if Prometheus thinks the problem is gone, then it will like tell Alert Manager, oh, it's resolved, and it will also disappear in Alert Manager. Yeah.
The problem that the administrator didn't notice the alert the first time.
Yeah. Yeah. Then if the problem still persists, then you can get repeated notifications through Alert Manager. Yeah. Oh yeah, and I will think about repeating questions actually. Yeah.
So when I monitor our Kubernetes cluster and all the services running in there, do you suggest to run Prometheus inside the cluster or outside?
Yeah. So the question is, better to run Prometheus inside the Kubernetes cluster or outside? We recommend inside, because then a lot of stuff gets taken care for you automatically. You get the service account stuff mounted in automatically, and it works network-wise to reach all the pods automatically, right? So yeah, we recommend that. And then of course it's nice to still maybe have some Prometheus outside of the cluster or some other meta monitoring that checks whether the one in the cluster actually works. Yeah. Yep.
Yeah, can you give some indication on how many Prometheus servers you need for like the number of instances that you have to monitor?
Yeah, how many Prometheus services per instances to monitor? I think it really depends on how many, the bottleneck is usually the number of time series. So if your instances export like 5 time series each, you can have, I don't know, multiple thousands of instances. But if each instance has like 10,000 time series that it exposes to Prometheus, then you can have far fewer. The budgets that you have to think about most is a single Prometheus server can do, if it's a big one, can do like maybe a couple of million of time series at a given time. A time series is every unique combination of labels that is currently relevant. So metric name plus like all the, you have to multiply to get like all the different values that each label can have, and multiply that for all the different possible labels to get the total number of series you're going to ingest, and then times the number of instances or pods you have, and that gives you an idea of your budgeting there. Yeah.
So does it just start to slow down ingestion when you're breaching some of these limits?
Yeah, like it starts to slow down ingestion, but you might also just find that your queries don't return anymore. If you have, like, one very common error at the beginning for Prometheus users is like once they find out how useful labels are, they put information into the label values that is too unbounded in cardinality, like a user IP address or email or something, and there could be millions of those, right? And that gets multiplied with all the other cardinalities of all the other labels, and then you suddenly have like 1 billion time series, and the Prometheus server just instantly dies. And then you can neither ingest nor query or anything. So yeah, you'll get slow ingestion or missed, like failing scrapes, and also slower queries or failing queries or so. At some point it'll just blow up. Yeah.
I was just curious what features you see as being in the roadmap for Prometheus, like a year from now. What would you like to see?
Yeah. Roadmap features for Prometheus in a year from now or so. So Prometheus as a whole is probably not going to change that much anymore in terms of its scope and what it wants to do. There's some things we have, like we have an official roadmap section on the site that has shrunk and shrunk and shrunk every time we have crossed out some of those items. One item that's still on there is making better use of the metadata. Like when you instrument something on the side of a process that exposes metrics, it actually exposes still some metadata about the metrics, like what each metric means, like a help string, and also whether it's a counter, a gauge, histogram, or summary metric. And the server, when it stores that information. Just the first thing it does is throw that metadata away because we don't have any facility to store and make use of that yet. And so one roadmap item is still somehow temporarily aggregating at least that metadata in memory in Prometheus so that we could give you some hints. Maybe if you're formulating a query and you're doing like a rate over a gauge, we can tell you like, oh, you're trying to do something that might be not as you intended here. Rates can only be done over a counter type metric or things like this. That's one thing. More robust remote storage integrations is definitely a thing that's still being explored. We had this initial interface where Prometheus just sends samples in a real-time, almost near-time, real-time kind of way to a different endpoint that I talked about. But then if your Prometheus server is down for, or like the network connection to a hosted service that does the long-term storage for you is like down for 10 minutes, then you just lose 10 minutes of data. And there's some other approaches that are more about shipping whole chunks from a Prometheus to some remote system. One of them is called Thanos. I really recommend looking into that one. I think those would be the main areas. Always looking for more integrations, and yeah. But I think as a whole, Prometheus is pretty set, the scope. Yep.
So let's say in the Kubernetes cluster, you have enough load that requires me to have a cluster of Prometheus box to monitor, right? Then how does it balance the load among them?
Okay, if you have multiple, so if one Prometheus server is no longer enough, then, as I said, Prometheus doesn't do automatic horizontally, like push button scaling. You have to kind of think about how you split up the load over your Prometheus instances. If you search for a blog post, I think Prometheus scaling and federation, that's a good overview. There's different strategies. You could, like one example is, you have 10 data centers. One Prometheus is enough for each data center, but not for all. So you could have one Prometheus per data center, or this could also be an in-data center thing. That monitors all the detailed metrics within that data center, or that cluster, or whatever your units are, and then you have a global one that federates some of the aggregated stats from the lower level ones, but doesn't have all the detail anymore. So you have the global view, but not all the detail in the top. And in the leaves of that tree, you would have the very detailed instance level view, but no longer the global view. That's the kind of hierarchical scaling. There's some ways of doing limited types of horizontal sharding as well, where you can have like, you have one service in one data center that's just 10,000 instances and they cannot be scraped with one Prometheus. You can configure 10 Prometheuses and say like each of you only scrape a subset with like a mod sharding approach. And then in a query, you can still combine the data again. Yeah, I think we're probably out of time, right? Yeah, sorry. Cool, thanks.